think, I was thinking, oh, weird. I did send reports home Monday. Tuesday, whatever the day was. My computer kind of froze off and it kept sending reports over and over. So some of the parents got like 4 reports. So it did kind of screwed up a little bit there, but you should have got a lot of reports in them. But people think when the day is called off, like yesterday or the day before or whatever day, it's sit at home do nothing. I actually got all of you, like I said, calendar made, tests made for the next 2 chapters, lessons made, so I did really good the last couple of days, getting everything made up and going. Now, what we've been doing on this, once you pay attention, what we did in the first 2 sections, we did some graphs, right? First section, we graphed some equations. In the second section, then we started saying, okay, how do we determine, we did graph the sections and found a point in the intersection, I should say, first. Right? The second section we did elimination and substitution. We didn't graph it, we said, okay, let's find the answers. It's a little easier to do elimination substitution when the graph's there. Now you'll notice today's equation is a little different. Today's is greater than or less than, or equal to, and all these things. It's inequalities, that's the key word here, inequalities. And inequalities we're going to have where, back to the days when we did some graphing, we're going to shade. We're going to shade, and we're going to look for answers that work. And a couple of points I want to point out before we get going on it. If the equation is just a less than or greater than symbol, what kind of graph is it? The dotted line. It's dotted line. Okay, and it doesn't have to be just a line. It could be an absolute value, where it's a dotted B. It could be a dotted B. It could be a dotted curve, or whatever it is, right? If there's no equal sign there, it's dotted. If it's an equal sign underneath here, like here, I'm going to show you that little equal sign, then it's a solid line. Okay. Now everybody says, well, how do I determine where to shade? I always go back to the original equation just in case I make a mistake. But to graph these, what I might want to do is I'm going to take this first equation right here. To graph this, what I might want to do is try to get x, or not x, but y by itself, right? So what would my first step be?
Add 2y to the other side.
Could add 2y to the other side, okay. That would be one way. I love the y.
Wait, are we trying to get x by itself?
Or get y by itself.
Oh, then you...
But that's okay, we can do it this way. That's actually probably easier. If I'm going to get 2y by itself, I'm going to do this, and then what?
Minus 6.
Right, 6. So I'm going to get x minus x minus 6 is less than 2y, and then what?
Divide by 2.
Divide by 2. So
say we had done it the other way and I'd moved the x.
Yep.
Because we divided by a negative, we would have had to flip the sign, right?
Correct. You would divide, if you divide or multiply by a negative, you flip the sign. It goes from greater than or less than.
Is that still standard form? So can you have just done negative a over b?
You could do a negative a over b, yes. If you, it is still standard form, even though it's an inequality. Because we're just graphing, you just kind of look at that way too. So, I like this doing this right now. If you want to use a negative a over b and a c over b, that's fine. Either one works here. Now what I'm going to do here is I'm going to graph these 2 equations. I'm going to start with this one down here. If I'm looking at this equation, it's in the form of mx plus b. My b is going to be negative 3. I'm going to start at a negative 3. So I'm going to go down to a negative 3 here and put a dot. My slope on this equation is 1/2. I'm going to go what? Up 1 over 2. Okay, up 1 over 2. Up 1 over 2. And I'm going to keep doing that. Oh, there we go. And it's a dotted line, correct? So I'm going to go up here and I'm going to get my dotted line and I'm going to draw. That's pretty good. Draw my dotted line here. Okay. Okay, I got my graph. Dotted line and everything like that. Now what?
0, 0, and you decide which side to shade on.
Yeah, I had to decide which side to shade on. I'm going to use the shade below or above. Easy point to try is 0, 0 because it doesn't go through the graph, correct? Now I'm going to go back to the original equation. Just in case I made a mistake here, could have, right? I'm just going to go back and check my points off. 0 minus 0. 0 is less than 6. Is that true? Yes. If 0 is less than 6, then it's true. I'm going to shade where that point is. So on this one, I'm going to shade above here. I'm just going to draw some lines like this. I'm going to shade above. Just like that, okay? Got that one done, right? There's my one equation. Shaded above, got the points. Now, and remember, when I shade above, it means it goes on. Some people think it just stops here. It goes on forever above. It doesn't stop. It keeps on going this way, it keeps on going this way, and it keeps on going this way, okay? Now, my other equation, where would I start on my other equation? At 5. I'm going to start at 5 here. I get my pen to work. There we go. I'm going to start at 5. There's 5. What's my slope?
Down 3 over 2.
Down 3 over 2. 1, 2, 3 over 2. Okay, there's my point. And I think this one's going to be a solid line because this is an equals here. Okay? So we're going to do a solid line here. Solid line. Okay? We can try 0, 0 again because the point doesn't go through that line. Here's 0, 0, right? So let's go back to here. 0 is less than 5. That's true. So we're gonna shade where 0, 0 is, right? I'm gonna use green this time. I'm gonna shade where 0, 0 is. 0, 0 is on this side. So I'm gonna shade down this way. Okay? Now it looks like a mouse. But where's my answer? Point of intersection. Now I'm going to go like this. I'm just going to make this a little bit larger here. My answer, and some people do it this way, I'm just going to shade it. See if I can get there. Is in here, right? That's where they overlap, right? Now I want to point out a couple things. First of all, it goes on forever. Again, right? The answer is here because they overlap, right? It does not include this line because it's dotted, correct? But it does include this line because it's solid. But it only includes this line from the dotted line above. It only includes that much of it, okay? So when we look at it solid, okay, we're going to include that. If it's dotted, I'm not included. A point on there would not work. So a point here doesn't work, a point on that line works, and a point inside here always works. Okay, I'm looking for the answers. Now what happens when I have a different area now, this is where it overlaps, right? Think about what I did here. I started with the red line, right? If I picked a point here, is it overlapping? Which color is there?
Red.
Red. A point in this area only works in this equation. It works in this one, but it doesn't work in that one. Okay? Now down here, what? That one's wrong too. It's green, right? Now if you remember, green was this equation, right? So that means it works in this equation, but it doesn't work in this one. Now how about the area right here?
Works in neither.
It doesn't work in either equation. A point down there won't work in either. So kind of how it works. You've got one area that works, one area is going to work in one equation, one area is going to work in the other, and one area is going to work in neither. So you've got a whole bunch of areas on it. Okay. Now I had a question last hour. How do you determine, how do you show this on a test where your area is shaded? Okay. Well, I kind of do this. Some people take a pencil and sideways shade. Some people use colored pencils at the end and shade where the answer is, correct? You know, some people, and one thing I want to point out is this. Some people are really nice and neat, and they go like this and say, okay, I know it's this area right here. And put a little box around it. I don't like that. I want you to show me that the area goes on for that. Just keep shading up like it doesn't have a square to it or anything like that. Because some people think it's just that little box there. No, it goes on forever. Okay? And there's many answers. You know, some people say, how do I get this to work best? You know, and it's tough because we have two equations here. We have two equations. One of the problems we did last hour, we had 6 equations. And we now shade 6 equations. When you have such different coloring all the way around, it's hard to tell where everything is. So, I mean, that's kind of where you have to kind of get used to seeing what you're looking for. Good? I'm going to give you one now. I want you to try this one. I want you to shade. Just graph the equation up. We're going to do a lot of graphing today. Come around, look around the sheets, see what you get. Graph it up. So here's my first problem now. The first one, I always go through and start making notes to myself. On top equation, we got a less than or equal to. What do you think? Solid or dotted? Solid line. It's going to be a solid line. Bottom one is just a greater than, and so it's going to be a dotted line. I kind of put no, so make sure I remember that. Also, these are nice in that they're in kind of order here. This first one, where would I start? Start at 4, so I'm going to go up to 4, put a dot here, and then my slope is down 2 over 1, down 2 over 1, down 2 over 1. And we said that the first one is a solid line, correct? So I'm going to go get my solid line here. Let me change that one a little bit. There we go. Now we have the shade. Now which was a good point to shade on?
0,
0,
0.
0. Since it's not on the line, it's an easy point to try. 0 is less than 4. True. So we're going to shade on that side. So I'm going to go back over here. I'm going to pick green again if I can. There we go. It's a true statement, so that side is 0. Correct? Next one. How hard an equation x is greater than a negative 3? What kind of equation is that? What kind of graph is that? It's an undefined slope. It's a dotted line, right? And it's going up and down, vertical line. Yep. Yep. Vertical line. X equals, think about x. X is always, this says x is greater than negative 3. It means x, just think about this equals always. X equals a negative 3. X equals a negative 3 means it's always a negative 3. So what I'm going to do is I'm going to go over to a negative 3 here. Here I got 1, 2, 3, and I'm going to draw a dotted line all the way up and down at a negative 3. I'm going to draw a dotted line. Actually, go a little bit further here. There we go. Dotted line, straight up and down. That's what x is. Now it's dotted because it's greater than, no equal sign there. Now if it says greater than, what side would I shade? Points are larger, right? Which way does it get larger? Going to the right. Sometimes I could try a point. I could try 0, 0. If I plug 0 in for x, 0 is greater than a negative 3. Is that true? Yeah, I can still try a point. It ain't going to hurt anything. But I mean, x is greater than, you should know it goes to the right. So if I was shading that one, I'm just going to get a color here. Let's go orange. Go this way. There's our x is greater than negative 3. Okay? Now, if I look at this, what's my answer? This area inside here, right? Not including this line, but including that line. Now, I want to be a little careful here. I'm going to draw my line again here. This line keeps on going. Will it stop right here? So really my answer, if I was drawing my answer, and I'm just going to draw it, it would be in here up to that point. It wouldn't go forever that way. It would go forever this way. These two lines intersect right about there, so that's where it's going to stop. That makes sense? So any point in here is going to work in both equations.
So is that your answer then? You just choose a point from there?
Yeah, you choose to say wherever you got double shaded or your final shaded region, that's your answer. Yeah. It's not like on the previous problems we had a point. Those are just 1 point. This is a lot of points.
So you just choose any in the...
You don't have to choose. You just say. A lot of times what people do is go like this. I'm just going to pick up more yellow. To finalize their answer, they will highlight this area in here and say, this is my answer. Okay?
You just want to show that?
Show that area. All right. You know, we have to be a little careful with it sometimes. Let's say, I'm going to try to finish this up here. Let's transact it up a little bit here. So that's my answer, okay? You need to be careful if you're doing a word problem. Okay? Reason being is, let's say this was a problem dealing with multiple. There's one coming up. Okay? Okay, could I have any number in that shaded region? Well,
It can be opposite negatives.
can be negatives, right? Down here or here, right?
So it's just that.
So it would maybe do this little area, right? And then you might want to put a little note off the side and shade that area and put a note off to the side and say only integers or something like that, because Well, I don't know the last time you made 2 2/3 loaves of bread or something along that line, you know what I mean? You probably make 2 loaves or 3 loaves, but you don't make 2 2/3, right? So that's kind of where you have to read it. If it's just a regular problem, yeah, you're gonna shave the whole year. If I was dealing with money, could I have 2.3? Yeah, $2.30, right? But if I'm dealing with something else, maybe it's hard, number of people. You know, it would be harder. That makes sense?
Yep.
Okay, so what I want you to do now is this one. I'm gonna move ahead a little bit here. That one right there. I'm gonna reset the thing here. So I want you to try that one next. Graph it out. A little different again.
Like I said, a lot of the questions you gotta look at, these questions, you might wanna write down notes. Like if I was doing this one, I'd look at the first equation. Solve line or dotted line?
Got it. There's no equal sign. You want me just a little note to myself, not a line. Second equation. Solid. Okay. But the second equation is not a line really, just one. What is it? Absolute value. So it's a. It's a little different, right? Not much. Now comes the hard part. Let's see who remembers. X minus 3 inside the bracket. Absolute value, correct?
3, right, 3x.
It moved, I heard you say move to the right? I did this morning. I was like, people are moving to the left, down, up, everywhere. But this one is X minus 3. What makes it 0? 3. That means it moves, if it's inside, it's going to move it to the right 3. It's very slow. 101. So this one, this bottom equation, I'll start with the bottom equation here. My bottom equation here, I'm going to move it over 3 units. Here's my point. Right there. And then my slope on that equation is 1, the number in front of my x. So I'm going to go up 1 over 1. Draw my graph in. Solid line because it's the equal sign there, right? Solid line. And so therefore I got those. And now I have to pick a point. Well, which point did I try? 0, 0. It's an easy point to test. My test value. I call it my test value. Try 0, 0. 0 is greater than, let's see, 0 minus 3 is 3, negative 3, absolute value is 3. So 0 is greater than 3. No. So it's not going to be out here, so it's going to be on the inside. So I'm going to shade the inside here. Good. Watch on that. Now my next equation. Y. Now last problem we did is x, right? X equals was a straight up and down line. This is y equals, so it's going to be a horizontal line at 4. So we're going to go up to 4 here. So we're going to go to 4. 1, 2, 3, 4. It's going to be a dotted line. There's no equals there, so I'm going to have a dotted line at 4. Right there. Correct? Less than 4 means what?
Below the line.
It's going to be below the line. Okay? So if it's going to be below the line, I'm going to go back over here. Below the line, I'm going to stay down here. So, where's my answer at? triangle right here, I'm gonna throw it here. Here. There. So it's going to be the area inside, right? This side, yes. This side, yes. Dotted line, no. Okay? We're looking for that area. Any questions on that? Okay. Now we're going to switch up a little bit. Okay? I do want to cover one more thing. So one of the problems I want to cover, but this is not going to be for the whole class. So we're going to cover that one tomorrow. I want to cover, I want you guys to look at number 16, is if you are pre-calculus, look at 16. We're going to go on that board over there and work.
What page?
Page 132. 16. If you're the other section, I'm going to give you homework. Your homework today for the other section is going to be, let me get here. Page 132, 1 through 27 odd. Okay. If you want to switch groups, you got to the day to do it. We're going to be moving, but 1 through 30, page 132, 1 through 27 odd. We're actually on that board over here. Just move it. Pick a desk over there. We're going to go through that problem real quick because they're going to cover the whole section. Your guys' assignment, if you did not get it, is page 132, 4 through 50. Yeah, 4 through 54 or 52. 4 through 52 by 4s. So we're going to group. So go to work. We're going to talk about a word problem real quick. We'll cover that word problem tomorrow. So your assignment 1 through 20. Okay. Sunday go back on the What page? 132. 132. 127. Okay. This one. We have two local equations. And let me start writing two equations down. So, take a marker and write it out. Hello? Yes. Yeah, I can send him over in a couple minutes. He has to walk, so it'll be a little bit. So. Yeah, bye. Yeah, start working on that real quick. I'll be right back.
What is the ratio? Yeah.
Jordan Fisher, please come to the office. Jordan Fisher.
See, that's what I'm thinking. It's like, what does she have in mind?
If you graph one,
I think so. Do I?
She just plug them in and see if they're.
No, don't keep going.
You have to graph it and then see if that point, like that part, the shaded part.
All you have to do is see if it's greater and then just plug the number in there and see if it's.
Well, if you look back at example one, it shows you
Okay, how would you?
Yeah, they show you about graphing, so we better graph it.
I use
Because if you want
B
size
and
down.
You can start at two.
The one that.
Twice is what?
Second, no, first.
You want to start your y?
with at least.
Okay, question.
Yes.
For instance, you use two variables or one?
Sure.
Okay.
And you wanted this in two equations? And actually, it's gonna be almost 5 equations.
One is five, because I'm not, there's no way I can. make
You could have
this.
3, but there's
None.
two equations that most people forget. I wanna talk about, right? Okay, you have 3 equations, I'm guessing right now, okay? One of the, you have 2 different mentions, right? You got banana, right?
Going long ways.
And I can't spell banana ever. And y is, one of the things I like about this is when we put you in a group, I might do it in the room. All of you are gonna be teachers. Cause I'm gonna have you guys.
So then now this will have to rearrange.
So, okay, this already fits. I always do it like this. That's maybe tomorrow. Why? The first equation I always do is the second line. It says here, don't even worry about the twice thing. At least twice the thing, right? The thing I want you to think about is just think about, and not at least, just say twice the thing. Which one's more? Banana or banana's good, right? How much more? Twice more. At least twice more. Don't worry about at least right now, okay?
We were graphing.
And now the thing is here is this.
Like, I don't get.
Everybody.
Okay, I'll be right there. Okay.
That's why I'm in this side of the class.
Because what happens here, let's think about this way.
And they're counting.
Let's say banana was 8 and now it's twice the thing. Now if I put the 2 with the x, what happens?
Because we're not dividing the
It's bigger,
negative.
yeah. Right? So how do I make them equal?
We have two x.
I put a 2y. Now they're equal, right? But I don't want them equal. I want the banana to be greater than that, right?
Look how X.
Greater than or equal to. Always think about how to make them equal
Let's
first,
shade this one first.
and then do the equivalent. That's the easiest way to do
Any
it.
elevation
Right?
above or below, we get it.
Now the second two, the next 2 equations is this. How many of those are
But
I
we can
doing?
plug 0, 0 in, right?
No, it's probably
Less
8
than
or
equal
10.
to 12. Need 6 or less than or equal to 11.
Okay, at least 6. So I'm gonna say greater than or equal to 6, right? So less than or equal to
Is that true?
I don't think so.
okay? It has to be between 6 and 11. What has to be between 6 and 11? X plus
Okay.
1. The number of moles together.
Now the next part, we're
Now,
gonna start.
I probably would
we're
take
gonna
these
start
2
on
equations and separate them. So what I would mean by this is this, I would go like x plus y is greater than or equal to 6, that's this
the
side.
bottom equation of that first.
And then
one,
this
the
side over
bottom
here would be x plus y is less than or equal to 11. I'd separate
one.
the
We're gonna graph this one, start at 2.
And they're going always over.
X.
So here's 1,
And what's our slope?
Here's 2.
From the x.
here's
1, up 1 over 1.
I told you 5.
I'm gonna need one to figure out.
We already have twice the thing. And we make that alone,
Okay,
so it
now
has to
we
be
can
x
shade
is
above
greater
or
than or
below.
equal to 0 and y is greater than or equal to 0. I can't have negative poles.
Not with our minds, we can use it.
The most poles I can have, but at least amount of poles I can have a banana is 0, right? The least amount I can have a, not,
Greater
is
than
0.
2.
So that's
Or
what
0
rather
greater
equal
than
to.
2. No.
So what you need to do now is you should take it, I'm going to do this, you gotta take these equations here,
Greater than 5.
graph them, and see
All of
what
it?
it's about.
Is that right?
Okay? Mullins? Any questions on that?
So you're gonna have to graph this one, and graph this one, and then wherever, like, you can yellow, wherever you start, that's your solution. That's your, what we're solving part of the.